Welcome to my lecture. Today we are going to solve one problem related to the Olympiad mathematics. So here the problem is number of real x for which this inequality holds 3 to the power x plus 9 to the power x equal 27 to the power x. So this problem is particularly in this format, but it can be applied for any number. So let's start. First we denote a equal 3 to the power x. Then a simple calculation will gives you a square is equal 9 to the power x, and a to the power 3 will gives you 27 to the power x. Therefore, the given equation will reduce to now a plus a square plus a to the power 3. Then rewrite it or rearrange it in this form. AQ minus a square minus a is equal 0. So take out a, and then you will have a square minus a minus 1. So product of two factor is equal 0 if any one of them 0, both of them 0. So let's take first a equal 3 to the power x, which is never be 0 for any x. So therefore we left with a square minus a minus 1 is equal 0. Now this is a quadratic equation, and to find the root of the quadratic equation, we will use this formula. So if you have this quadratic formula alpha y square plus beta y plus gamma equals 0, then y will be minus beta plus minus square root of beta square minus 4 alpha gamma over 2 alpha. So using this formula, we are now going to solve that equation. A square minus a minus 1 equal 0. So which will gives you a equal this form, and then after simplification you will get it 1 plus minus square root 5 over 2. Next take a equal 1 plus square root 5 over 2. Then this is equivalent to 3 to the power x 1 plus square root 5 over 2. Now we take the ln on both sides, and then you will have the answer equal x equal ln 1 plus square root 5 over 2 over ln 3. Now if x is equal 1 minus square root 5 over 2, then 3 to the power x equal 1 minus square root 5 over 2. The left hand side is positive and right hand side is negative. So it is not possible for any x. So this option is not possible anyway. So therefore we left with the only one real x for which the given inequality holds.